Hello students, and welcome to the revision module of straight lines. So here we try to complete the straight lines chapter with very fast revision of all the pointers. Okay, the first pointer is slope of line. Okay, so slope of line is denoted by letter M. Now how to find slope? There are three options in which you can find the slope. First is tan theta. Now theta here students, this theta is acute angle made by the line or angle made by the line with positive direction of x-axis. So as you can see in the diagram, theta is angle made with x-axis. The second way to find slope is y2 minus y1 upon x2 minus x1. For this method, you require 2 points on the line, that is x1 comma y1 and x2 comma y2. Okay students, now the third method is minus a upon b. This method is a shortcut to find slope when equation of line is ax plus by plus c equal to 0. Okay, so it is coefficient of x upon coefficient of y with a minus sign. Fine. Now the things to note here or to memorize is when lines are parallel, their slopes are equal. So if question says lines are parallel, you should take m1 equals to m2. When lines are perpendicular, product of their slopes is minus 1. That is m1 into m2 equals minus 1. Okay, or you can remember here that m2 is minus 1 upon m1. That means slope of second line is negative reciprocal of slope of first line. Okay students, now the second pointer is equations of line. The first in equations of line are standard lines. For example, equation of x-axis. Now as you can see in the diagram, equation of x-axis is y equal to 0. Okay, the second is equation of y-axis. Equation of y-axis is x equal to 0 because every point on y-axis has x coordinate 0. The third is line parallel to x-axis. When a line is parallel to x-axis, its equation is y equals k. Okay students, now why y equal to k? Because every point on this line will have y coordinate as k. Okay, and the last one is line parallel to y-axis. When a line is parallel to y-axis, its equation is x is equal to k, where k is distance of that line along x-axis from origin. Okay, the next type of equation of line is slope point form. In slope point form, as the name says, slope and point is required. So look at the given data. It is m, that is slope of line, x1 y1, point on the line. So if these two things are given, then we can find equation of line as y minus y1 equals m into x minus x1. Here we substitute x1 y1 and value of m. Fine students. The next type is 2-point form. Now as the name says 2-point form, look at the given data. It is x1 y1 and x2 y2 as 2 points on the line, and then equation of line is y minus y1 upon y2 minus y1 equals x minus x1 upon x2 minus x1. Now remember students, here x and y are variable point on the line. Okay, so x, y are the coordinates of variable point. We never substitute values of x and y while finding equation of line. The next form is slope intercept form. In slope intercept form, we require slope of line m and y intercept of line c. Now what is y intercept? It is the y coordinate of point where line cuts y-axis. Okay, let's understand this. Consider this line L. It is cutting y-axis at some point 0, c. This C point is called as y-intercept. So you may also say that this is C. Okay, now if the line cuts below origin to the y-axis, then C might be negative. As it is cutting above the origin, C is positive. Okay, and equation of line is y equal to mx plus c. Fine students. Now if you look at this C, if we take the line parallelly downside, then C will reduce, and when line passes through origin, that is this point, C will become 0. and hence we note here that when line passes through origin, that is C becomes 0, then equation of line is y equal to mx. Okay students, so this kind of equation appears when line passes through origin. Okay, so the next type, let's move on to next type. It is called double intercept form, or they also say it as intercepts form. So what is intercept form? It requires given data as two values a and b. A is the letter used to denote x-intercept of line, and B is the letter used to denote y-intercept of line. So students, you can see that very clearly in the diagram. A is this value, you can see it here, right? A is this value and B is this value. That is where the line cuts y-axis from origin. Fine. So if x-intercept and y-intercept are given, then equation is x upon A plus y upon B equals 1. The next one is normal form. Normal form requires P and alpha as the given data. Now let's look at P. P is the length of perpendicular from origin to the line, and alpha is angle made by this perpendicular with positive x-axis. For details, look at the diagram, students. Let us consider this L line has distance from origin as P. So distance from origin is P. Okay, and this perpendicular that is drawn from origin to the line, that makes an angle alpha with positive x-axis. And hence, when these two things are given, then equation is x cos alpha plus y sin alpha equals P. Okay, the next type of equation is parametric equations of line, or we can say equations used to find point on the line. Okay students, these are very important for our entrance exams. Now look at the given data. x1 comma y1 is a point on the line. Theta is inclination of line and r is distance of the required point from given point. So what do we mean by all that thing? Let us say there is a line L for which we want equation. Okay. On this line there is x1 y1, a point given. Okay students, this is a given point. There is a given distance r and we want a point on this line, that is x comma y, at a given distance r. Fine. Then this x and y can be obtained using parametric equations. So x is given by x1 plus or minus r cos theta and y is given by y1 plus or minus r sin theta. Now students, if you look at these two formulae, here x and y can be obtained. What is x and y? It is a point on the line at a desired distance r from the given point. Okay, so parametric equations are the only equations used to find point on the line at a desired distance. Okay students, the next part is general equation of line. Most general form of equation of line, yeah, as you all know, it is ax plus by plus c equal to 0. Now students, as it is general equation, it can be reduced to different forms. So let us see reduction of general equation to slope point form. So we will be given an equation of this type and let us try to reduce it to slope intercept form, that is y equals mx plus c. Okay, so ax plus c is minus by, and when we divide by minus b, we get y is equal to minus a upon b times x plus minus c upon b. Okay, and when we compare this equation with slope intercept form, we get slope of the line is minus a by b, that is coefficient of x, and y intercept is minus c by b. Okay. Okay, now we try to reduce the general equation to double intercept form. Okay students, so we have taken ax plus by plus c equal to 0. We shift that c on right hand side, that is minus c, and when we divide by minus c, we get 1 on right hand side, and LHS becomes ax upon minus c plus by upon minus c equals 1. And when we take a in the denominator, it becomes x upon minus c by a plus y upon minus c by b equals 1. and this is somewhat similar to double intercept form. So when we compare with double intercept form, we get x-intercept, that is a, as minus c by a, and y-intercept is minus c by b. The next pointer is reduction of general equation to normal form. Okay, students. So again, we take the general equation of line and we try to convert this into normal form, that is x cos alpha plus y sin alpha equals p. Okay, for that what we do, we shift the c on right hand side, it becomes minus c. We dividing by under root a square plus b square. This is a key step, students. We have to remember this. When we divide by under root a square plus b square, then the obtained answer itself is a normal form, and when we compare with x cos alpha plus y sin alpha equal to p, we get cos alpha, that is coefficient of x, as a upon under root a square plus b square, and sin alpha is b upon under root a square plus b square, and p, that is distance from origin, is minus c upon root of a square plus b square. Okay, students. Now, when we want to tally, we can easily tally from these two that cos square alpha plus sin square alpha always becomes 1. Okay, and hence we have to divide by under root a square plus b square. Okay, students. Now, here p value is minus c upon root of a square plus b square. But while solving the problems, we have to remember that p must be positive as it is distance of line from origin. Okay, students. The next pointer is intersecting lines. Let's look at two intersecting lines. So when two lines intersect each other, their point of intersection, students, this is very important. Point of intersection is obtained by solving the two equations simultaneously. So whenever you want the point of intersection of any two lines, we solve their equations simultaneously. Now, similarly, when three or more lines intersect at a point, they are called concurrent lines. Okay, students. So, what are concurrent lines? When three or more lines pass through a single point, they are called concurrent lines. In the diagram, you can see L1, L2, L3 are concurrent lines. Okay. Now, in exam, sometimes they might give us three equations and they'll ask, find whether these three lines are concurrent. For that, what we do, see here, to check concurrency, we can solve the equations of any two lines simultaneously and substitute the point of intersection in equation of third line. What does it mean? We can solve any two simple equations, students, either L1 or L2, and otherwise we can take L2 and L3, and when you solve L1 and L2, let us say we will get point A, point O, and then we can substitute that point O in L3. If it satisfies, that means L3 also passes through the same point. Okay. Otherwise, we have another method to check concurrent lines. That method is here. Lines A1x plus B1y plus C1 equal to 0, A2x plus B2y plus C2 0, A3x plus B3y plus C3 0 are called concurrent if this condition holds true. That is, determinant of A1 B1 C1, A2 B2 C2, A3 B3 C3 is 0. Okay, students, we saw two lines intersecting each other, three lines intersecting each other. Now let us see what happens when four lines intersect each other. That pointer is called as family of lines. Okay, students. So let us look at family of lines. Family of lines concept says if u equal to 0 and v equal to 0 are equations of any two intersecting lines, then equation of a line passing through their point of intersection is u plus lambda v0, where lambda belongs to real numbers. Now what is this, students? Let us consider u0 and v0 as any two lines passing through a point, that is, they are intersecting. And this u plus lambda v is any random line passing through this point, let us say P. If U and V are intersecting, then P point can have infinite lines of this type. Okay, students, and all those lines are given by equation U plus lambda V equal to 0. They have a common type of equation. Only value of lambda keeps on changing. Okay, students, every equation of family of lines can also be solved by finding point of intersection. This we'll see elaborately while we solve some problems. Okay, students. So here we wind up the first part for revision of straight lines. Keep watching for the second part for rest of the chapter.